This video is sponsored by DFRobot. Hello YouTube and welcome to Heathen Hacks. If you're here from the previous video, glad to see you back. I assume that you've just finished the SOS beacon and have familiarized yourself with the 4 statements. If so, let's move on to the third project, traffic light or interactive traffic lights. Let's go! For this project, we are going to need the following items: the DF Arduino Uno board, prototyping shield, 13 pieces male-to-male jumper cables, 6 pieces 220 ohm resistors, 1 mini push button, 2 pieces red and green 5mm LEDs, and lastly, 1 piece yellow 5mm LED. Okay, here's the wiring diagram from the PDF. You can just follow along with me here while I connect everything. First, let's get our board, then mount the prototyping shield on top of it. Connect the LEDs in this particular order: red, blank, yellow, blank, green, 4 blanks, red, blank, and then green. Keep in mind that the LED's anodes or longer legs are on the right side, okay? Let's connect the resistors to the LED's anodes, followed by the mini push button right here on the 4 blanks or spaces that we have provided earlier. Connect a resistor onto the push button as well. This will serve as our input pull-up resistor. After connecting all the resistors necessary, let's connect the LED's cathodes or shorter legs to the ground rail of the prototyping shield like so. Next, let's connect the mini push button's other leg to the 5V supply. Then, let's connect the first red LED to digital pin number 12, yellow LED to digital pin number 11, connect the resistor that is connected to the button to the ground pin, first green LED to digital pin number 10, second red LED to digital pin number 8, the second green LED to digital pin number 7. And lastly, the mini push button's leg where the resistor is connected to digital pin number 9, and we're done. It does look a bit like a jungle of wires, but I'm confident that I've followed the PDF and have connected everything correctly. We can double check everything later on though. After wiring things up, let's see if it would work correctly by uploading the code. So here's the code that DFRobot has provided. Let's connect the board to the computer, make sure that we're using the correct board and COM port, and then upload the code. This is supposed to be a button-activated traffic light. This part right here represents the pedestrian lane's traffic lights, and these are the ones for the vehicles. At the moment, we can see that the pedestrian lane's traffic light's red LED is lit up. That's because the vehicle's traffic light's green LED is lit up or in go status, which means that the vehicles are currently crossing the road. If we press the button, the vehicle's traffic light would change from green to yellow to let the vehicles know that the traffic light is about to change and they need to slow down. After a few seconds, the yellow LED would then change to red to signal the vehicles to stop. When the vehicle's traffic light is lit up red or in stop mode, the pedestrian lane's traffic light would then change from red to green LED to signal the pedestrians to cross the road or pedestrian lane. After a few seconds, the pedestrian lane's green LED would start to blink to let the pedestrians know that it's about to change color or status. And when the pedestrian lane's traffic light has changed from green to red, the vehicle's traffic light would then make the red LED hold for a few milliseconds before changing it to yellow to signal the vehicles that it's about to change status to green or go. Just like that. Just for a demo, this jeepney right here would represent the vehicles and Jollibee would be our pedestrians on the pedestrian lane. So, vehicles are crossing the road. Jollibee wants to cross the road safely, so he pressed the button. It would signal the jeepney to slow down and eventually stop. Pedestrian lane's traffic light is lit up green. Jollibee crosses the road. Time limit's about to be reached. And stop. Vehicles are then signaled to stand by and then go. And there we have it. Based on the previous 2 projects, most of the codes on this sketch should be familiar and made sense right away. This project includes a data type called unsigned long. Unsigned long variables are extended size variables for number storage and can store 32 bits or 4 bytes of data. The long command we've used in this project can store integers from negative 2,147,483,648 to 2,147,483,647. Unsigned long cannot store negative numbers, so it stores integers from 0 to 4,294,967,295. If we use int, we might go over the limit of 32 seconds and risk having errors in running our sketch. As a result, we need another command to store integers and exclude negative numbers such as unsigned long, whose limit is 49 days. After declaring the variables, we enter the setup function to configure the LEDs and buttons using pin mode and digital write. We've set the LEDs to output and the button to input. We've also set the vehicle's traffic lights to start at green or go state by setting the green LED to high and the pedestrian lane's traffic lights to red or stop state by setting the red LED to high. Onto the void loop, int state equals digital read button. State is the variable we've set to read the button state of the button that is connected to digital pin number 9. Digital read is the command used to read the digital pin state whether it is high or 1 or low or 0. Digital read passes the signal to the variable state for further judgment. When state value is high or 1, it means that the button has been pressed, and the opposite if the button has not been pressed. If state is equal to high and millis minus change time is greater than 5000, change lights. On this block of code, we've used the if command to test conditions. If state is equal to high, or when the button state is pressed or return the value of 1 or high, and if millis, a command that returns the number of milliseconds since the board began running the current program, minus change time, the unsigned long, is greater than 5000, the function change lights would then be called. Change lights function would then turn the vehicle's traffic lights green LED to low or off, turn the yellow LED to high or on, wait for 2 seconds, turn the yellow LED off and red LED on, then wait for 1 second and turn the pedestrian lane's red LED off and green LED on. Wait for a duration of 5 seconds or the cross times value. After cross times value has been reached, the for loop would then be activated and would start comparing conditions. Then the pedestrian lane's red LED would turn on, wait for 400 milliseconds, then the vehicle's red LED would turn off. Yellow LED would turn on, wait for 1 second, and then yellow LED would turn off and green LED would turn on. After that, change time would record the time since the last change of lights, then return to the main program loop. That's it. I know that it can be quite confusing, so for a more in-depth explanation, please refer to the PDF. Click right here if you feel ready to move on to the next project. See ya!